Good afternoon, and welcome to EHS Today webinar, Machine Safety, Incorporating Interlocking Switches and Other Safety Devices. It's sponsored by PILS Automotive Safety. I'm Adrienne Selko, and I'm Senior Editor for EHS Today. Before we begin, let me explain how you can participate in today's presentation. First, if at any time you are having audio difficulties or slides are not advancing, simply hit your F5 key to refresh your webcast console. If you are running pop-up blocking software, you will need to disable it to view the webinar. And if you have any technical difficulties during today's session, please press the question mark help button in the upper right corner to receive assistance in solving common issues. This webinar technology allows you to resize the presentation by clicking the maximize icon in the upper right corner to enlarge the window. We welcome your questions during today's event. To submit your questions, simply type them into the Ask a Question window on the left side of your screen and then hit the Submit button. We'll be answering as many questions as possible during the Q&A session that will follow the main presentation, but feel free to send in your questions at any time. Also, be sure to check the Resources tab on your console for additional resources provided by PILS Automation Safety. And also be aware today's session is being recorded and will be available on the EHS Today website within the next day for you to review. You'll be notified by email when the archive is available. When the webinar ends, please take a moment to complete the feedback form that will appear on your screen. And let me introduce today's speaker. We have with us Brandon Cox, who is Territory Manager for PILS Automation Safety. Brandon graduated from Tuskegee University with an electrical engineering degree and has 15 years working for various engineering and design companies. He has been with PILS since 2017 and is currently a territory manager. For more about Brandon, please check out the Speaker Details tab on your console. And with that, welcome, Brandon. The floor is yours.
Thank you, Adrienne, and welcome everybody to today's presentation on machine safety. We will be discussing just different topics and concepts on incorporating interlocking switches and other safety devices. The objectives, what I want to do is I want to kind of review some of the standards that were involved in machine guarding. Also provide an understanding of the application requirements with guard safety measures, give an overview of machine protective devices, and just a couple different examples of electrical interlocks and other safety devices. And yes, I know there's a lot of them. We'll try to cover as many as we possibly can today. At the end, there'll be a Q&A for any questions that you may have. So with that being said, let's get started with the content. Just an understanding, this is a direct snapshot from the standard. So the ISO 12100 section and implementation of guards and protective devices. It's taken straight from that figure. It just kind of gives an understanding for what kind of flow happens, the questions that you would ask yourself if you happen to have a machine that could pose a possible risk to not only itself, but to the operators or engineers or any kind of resources that may be utilizing the equipment. Just a little snapshot of other applicable standards. So just a few just to take a look at, like, for example, the ISO 1385, this machinery safety. So safety distances to present hazard zones by being reached by upper and lower limits. This could be something utilized if you have moving equipment. So for like robot arms, if you've got a robot arm and you're looking for cohabitation or collaboration with that robot, you might want to utilize this safety standard as far as within designing your applicable applications. Just give you a little bit more time to look over those standards. So another couple more. But under protected devices shall be consistent with the manufacturer's instructions. So it has to be set up a certain way, and all shall be applied to prevent access to the hazard. Basically cause the hazard to cease before access. You would definitely want to prevent unintended operations. You don't want it to start up by itself. So if it shuts down, it should stay shut down. It could contain parts and tooling, so i.e. loose objects, flying projectiles, and it should control other process hazards. Small note there, each protective device may not address all the criteria above. Depending on the hazards being protected, multiple protective devices may be required. So within a system, it may not just be you might need a door switch or maybe a light curtain. There may have to be a safety mat involved. You may need different safety relays to actually control the functionality of your application. It may not just be one device that make you compliant to the standard, I guess you would say. Next, it's just for types of protected devices. These are going to be a little bit of what we're going to dive in today. So just from a snapshot, so mechanical solutions that physically prevent or restrict access. So like pull bags, you've got mechanical constraints, interlocked guards, automatic screens or doors. And we've seen those. These are the doors that fly up and down, just basically protecting people from the hazard. There may be lasers behind there. There may be a machine tool area. And also rotating tooling and fixtures. We've also got electrical solutions that create and stop signals. So like photoelectric opticals, light curtains with the screen or light screens. We've got area scanners, vision systems, radar systems, which is a new technology, hydraulic press brake safeguarding systems, as well as pressure sensing devices. So like the floor mats that I discussed, we've got safety edges and bumpers. You've got control devices, so two-hand controls, so devices that you may have to use both your hands in tandem to actuate or initialize the equipment. Presses generally have those types of equipment. Two-hand trips and single control devices. There's different definitions of safeguards. A safeguard is a barrier or device or a safety procedure designed for the protection of personnel. This has some caveats to it because a safeguard could be something that you're protecting the actual equipment from the user as well. We'll touch bases on that a little bit later, but different examples of that is guards, so some sort of mechanical barrier. You've got protected devices, so other safeguards like interlocking devices, your safety curtains, scanning devices, so area scanners, RF frequency capacitive protected devices, so something that's restricted to different radio waves back and forth, safety mat systems, two-hand control systems, again, as I mentioned before. With guarding and interlocking, there's different types of guards. You're going to have fixed guards. So these are like enclosed guards or distance guards. These are like if you've got some yellow guarding that goes around an equipment. So there has to be some sort of access point or not an access point at all. But this guard doesn't move. It'll be in the same place that you install, and it's there as a fixed location. There's also movable guards. So you've got the power operated guards. So it's like a door system possibly, self-control, self-closing guards, and controlled guards. We've got adjustable guards. So these guards may change their functionality just based off of operation, but the guard is in place to restrict risks to the personnel. And we've also got interlocking guards and interlocking guards with guard locking. We'll discuss that in just a moment. Interlocking guards. These are in place to prevent access during hazardous portions of the cycle and removes the hazards when the guard is open. So if the door opens up in the example you see there off to the right, the functionality should be coming to zero. It should hold at that position until the system is either restarted, that gate is closed, then restarted, or some other system or control device is initiated to reinitialize the equipment. It must observe safe mounting distances. So it has to be in a certain location, otherwise it may not mitigate the actual risk. It's going to be interfaced to the machine control system. So a lot of times you may have a door switch. This door interlocking keys to it to where you have access to the equipment if you have said key with the proper permission. There's also electrical devices. So you're going to have different switches and there may be some guard locking involved to where you're actually sending a signal even with a key before the door could actually open or that switch be initialized. Mechanical devices. I'm sure some of us have seen these in our everyday back and forth coming and goings. Mechanical devices generally going to have trap key interlock switch, and they work on the principle that no one key can be in two places at one time. So generally, this is what I was referring to as far as you'll have a hard key. With that key, you gain access to the application. So the risk should be minimalized based on a sequence of events. But with this key, you are the only one that can gain access to the application. Without this key, it will not start back up, or you will not be able to de-energize the equipment. So what this does is it gives you the opportunity to at least mitigate the risk of someone getting hurt improperly, because one key can only be in one place at one time. We'll discuss maybe some different innovations to this process going forward in just a little bit, but mechanical devices are used in place to verify and solidify your machine guarding or machine safety. Advantages. Generally pretty robust. So from like a stainless steel or brass housing available for harsh environments. There's no springs or cams that can fail. It's basically no wiring. You may have a pigtail. It may have a already punched end, but generally this mechanical device is pretty sturdy. It can be used in a lot of different hazardous locations. They generally can take a little bit of a beating as well. Disadvantage. As the more complex the system becomes, these can get pretty expensive based on their robustness and functionality. They can get fairly expensive, and there's other opportunities. There's other devices that can be used in place of, but for certain door locking situations, these are pretty applicable. Lost or missing keys can cause unnecessary stoppages. For example, you lose a key that you've just shut down the equipment. You lose that key, that's going to cost a lot of people a lot of time. So a lot of disadvantages in that. We would rather have multiple keys, but with multiple keys, you're adding to your problem, which is causing multiple opportunities for that equipment to create a risk for the personnel. And access to the area can be difficult for maintenance or loading. So a little bit of an SOP thing there. Guard locking switches. So guard locking switches require a safety rated signal to unlock or release the switch actuator. So for example, I mentioned you may have a key that may unlock the door, but you may not have the guard locking switch in place to where that won't release. It won't unlock unless there's another signal given. So you may have to unlock the door and press a key, or press a button and then unlock at the same time. This can be determined based on your control system, but generally you're going to get some sort of signal has to be sent for that door actuator to release. Guard locking from an access management perspective. So generally you'll have more of a software-based access portion to your interlock or your door switch. So without having the proper permissions to be in a certain area. So these may come with a key, they may come with a card. This is something that multiple people can have access to the exact same area based off of permissions or whatever group they may belong to. So if you've got a certain shift, they should be able to access certain equipment based on the access management keys or permissions you got set in place. These can be used from a security perspective, so they can actually protect the equipment from some users that may not need to be in that area. And it can also be used as a safety device as well. So you may have certain keys that may give you certain functionality. Certain access management will determine what type of safety this would be, but within access management, it is another guard locking function that can be used in tandem with different control functions. Okay. Different advantages and disadvantages with key operated switches and guard locking switches. They're very low cost. So these are going to be a little bit cheaper than the bulky, hard, and robust versions. So they will have a wide range of different sizes. They're going to be tamper resistant. So as again, I focused on access management. If you don't have the right kind of permissions or you're set to the right group within the software, you won't have access. So that mitigates out having to have a key that might get copied or a key that's lost. It unlocks only when the hazard motion has ceased. So definitely has more full control over if the risk is still in play, while a mechanical guard may not catch that, as it's only going to be a mechanical device that's moving without the control of some other device. So as we have a mechanical device that does have guard locking, we've gained more control of that because we can send a signal to verify that the risk has been minimized. And it protect machines and processes with a stop in mid-cycle could lead to a machine or product damage. So this could work in place to where you don't have stoppage in time because someone may have improperly accessed the area or created downtime. You've got full control over who should be in the area and why they're in the area. Different disadvantages. We've got additional maintenance required for alignment issues. So you may have to institute maybe some resources that are up to a certain understanding level of, if you're using access management, they may need passwords. They may need an understanding for how the equipment works. If it has some guard locking switch, so if it has to have a signal, that means there's some sort of control behind it. Is it through a relay? Is it through programming? This all could pose a little bit of a disadvantage because there's a learning curve to it. Access to the area can be difficult for maintenance or loading and unloading as well. So this isn't going to be an area that you want to have a lot of traffic through. This one, you want to maintain control of these kinds of areas. And the key is a single point of failure that may reduce the protection provided. This is in reference to if you've got certain kind of keys that are going into your interlock, they may have a single point to where they can fail and create an issue to where, oh, the key's stuck in there, so the system's going to continue to run. If it continues to run, then we're always going to be at a risk, because even as the safety devices are in play, they're not necessarily functioning properly. So there is a little bit of a disadvantage in that. Non-contact safeties and switches and sensors. So these are like our magnetic switches, our coded transponder switches, optical switches. The other types of safety interlock devices are available that require no contact between the switch and actuators. That's what these are. So you've probably seen these a lot on the closing doors. So they're very small, sometimes they're very inexpensive, but they have minimal alignment problems. They're definitely recommended for washdown areas. So areas within the food industry, they take up less space as needed when they're controlled. Other safety devices, so they're rather small. These aren't going to be huge devices. They're going to be real small. They're almost there for reference points. So like a proximity almost. Again, I said they're low cost and they provide protection if regularly checked and maintained. So a lot of times with them being so small, it's an advantage, but it's a disadvantage. You may have them on a door. If that door is getting a lot of action and is getting hit, it may become out of line or fall off based on the fact of its size. You may knock it off and not even realize it. But again, it's an advantage that could pose a possible disadvantage. Some can be bypassed with strong permanent magnets. So a lot of times what we tend to see just out in the field, either they will be bypassed because of understanding the technology and how they work. So with a magnetic switch, you got to deal with the fact that it's a magnetic switch. So if someone wants to bypass it, all they need is a magnet. These must be automatically monitored to detect defaults. And again, access to the area could be cause problems or just issues with loading and unloading. On the coded transponder side, so you'll have various components to these kinds of switches. They look very similar to the magnetic switches, but these have a coded actuator. There's an evaluation unit that's to come with it, but generally what you're going to have with these are, they're going to come with heads that are specific to those. So if you get these in a package, they're going to work together. And sometimes they come with some hysteresis, so where you can train them up to about 8 times. But if that isn't in place, it's not going to function the way that it's supposed to per the evaluation unit or control system. So you can't now bypass these with a simple magnet. These are a little more everyday usage. These ones, your system won't start if someone tries to bypass. So you're starting to mitigate out those risks of people probably improperly utilizing the technology to bypass and then becoming a risk to themselves, because the machinery is still going to operate in a certain way. Inductive switches, these are very similar to like proc switches. That's basically what they are. They're just triggered by any steel, stainless steel, or any kind of really metal. So these are very similar to like the magnetic. All you have to have is something there in front of it, and the inductive switch is going to pick up on that. So if it's metal and you've got it in front of it, it will pick that up, and your system could now become an issue or a risk to personnel that could possibly working in there. The door could be open. They may have it locked out properly, but now that it closes back, it may not need an actuator. So if it sees any metal, it could have the possibility of starting back up. So these are utilized, but I don't see them as utilized as I would maybe a code. The mag switches do have their purpose, but inductive switches have their locations as well. These will be rather on the cheaper side. So they do serve a purpose, and they are safety rated. They just have the disadvantage of being bypassed. So again, just touching on those advantages and disadvantages again. So with the coded, minimal alignment problems, recommended for wash down, less space needed. Disadvantage, must be automatically monitored to detect faults. And by that, what I'm saying is it has to be monitored basically. You'll see that something has to be paid attention to at all times. So it has to have some sort of feedback. They're going to have to reach a certain performance level. So it has to be monitored just to detect those faults. You can set it up to where it shouldn't or it can't, but in most cases, if you're trying to reach a certain performance level, you want it to be monitored a certain way so that it can detect a fault. So if something happens or something's being bypassed, your control system knows how to pick that up. Again, access to area could create issues for your loading and unloading. So could create a little bit of an issue there. And again, disadvantages being it could be bypassed with the metal object. So anything can bypass it, which therefore makes it very difficult to understand if maybe an issue may have happened with the safety system or if someone was just being malicious. Optical switches. With these, they utilize the same concept as like a light curtain, but the lights transfer basically through the fiber optic cables. So you can kind of see just different examples here to where they're utilized, but very similar to like a light curtain. Different advantages, minimal alignment problems, can be used in hazardous areas, can achieve Cat 4. That's a big thing. They're smaller in size, can guard multiple access points with one controller, and they provide absolute protection if regularly checked and maintained. So if you keep them up and keep them aligned, they will last. Disadvantages, they must be properly installed. If movement must be in axis perpendicular to the optical path. So you got to pay attention to it, and all of that you can find in generally your operation manuals. So as long as you're paying attention to installation, you should be fine. Access to the area can be difficult for maintenance as well. So a lot of these you're seeing that's one of the biggest disadvantages, and that should be a disadvantage because a lot of times you want your areas to be well protected. If maintenance needs to be done, you want that to be something scheduled. So if you've got a typical, this is where you normally see traffic, and now you start adding guarding to those areas, it may create a little issue with the way things had been done previously. But in the aspect of safety, these are the kind of things that you want to mitigate. Presence sensing devices, PSDs and photoelectric devices. So these are like your scanners or light curtains. Presence sensing devices protect persons and objects approaching within the safeguarded area. So you have with a light curtain, it's a series of beams. Those beams, if they're broken, something happens. Same goes for like the 2D scanners. So as they're scanning back and forth, what generally takes place is that area is broken. And with a scanner, of course, we'll touch bases on that in just a moment. If that area is broken, something should happen. And scanners generally are going to come with a little bit more functionality than a light curtain, but technology is basically one and the same. To effectively use any kind of pressure sensitive devices, the machine must exhibit the following stop performance characteristics. So it's got to initiate a stop upon receiving the stop signal. No full revolution stops, no cycle completion. The stop time is consistent, limited, and stable. And if the stop time varies, the worst case is used. So this comes with a formula. So when you're developing your performance characteristics, this is something that you got to take into consideration. You're going to have a formula that I'll show you here in just a moment. That'll give you like a stop time calculation. So therefore, when you do break that area, the machine or equipment should either come to a ramp, slow down, stop immediately, or not give access until it knows or the system is responding that there is no movement. So decent checks when you start getting into the pressure sensing devices. Light curtain and light curtain styles. Safety light curtains are photoelectric barriers composed of parallel infrared beams. So as you can see in the examples, there's a series of beams. If you break the beam, something should happen. Each beam is consistently monitored, and a stop signal is initiated when the object is detected. So if something happens, it sends a stop signal. Light curtains can also be used with mirrors to put more on one side. So you may have one light curtain that may make like an L shape. So it's just sending the beam through a mirror, and the mirror will then reflect to another collector or receiver. And now you've created more of an L-shaped barrier with the same light curtain instead of using maybe two different sets where that could get a little bit more expensive. So with light curtains, the advantages, protects anyone at the point of operation. It's large protected areas possible with one device. So again, with using the mirrors. Provides maximum productivity for frequent access operations. So if you've got maybe machine tooling, you've got maybe an application that has a lot of moving parts to where things are in and out. You have to do some checks. If a hand goes in there, something get lost. This will protect from those kind of stop times. Transparent to the operator. So there's no operator fatigue. It's not like these are beams that they can see and now they're blinding them as they're working on their work. These are infrared beams. You cannot see them, but if they were to break them, there should be some sort of stop signal sent to the equipment to slow down or stop the process. Disadvantages, it must be placed at the safe mounting distance. This is also with a formula within your operation manuals. You'll see this information somewhere within installation, but they may require adjustment for specific operations when using blanking. So you're going to have those kind of functionalities, blanking. You might have muting of some certain areas. You might have muting and blanking. And with those terms, what that means is with blanking, it's a certain area is just not going to be seen. You may have it to where product is moving through, so it has to be blanked out or muted. So as it's moving through the lights, you set up your control system to either ignore certain beams or allow product or something to pass through without disrupting the process. Supplemental guard may be necessary. Sometimes these are rather expensive devices, so you want to protect them with additional guarding. You may have a mechanical guarding that you may have in place in front of them just to keep like fork trucks or maybe some other risk from actually affecting the light curtain itself. Area scanners. With area scanners, there are photoelectric barriers which utilize rotating lasers that can be programmed to guard irregular shaped areas. So this is what I was referring to is with 2D scanners, you can actually create your areas. So these can come with configurable zones. These can come with just a typical safety zone to where if it's broken, something happens. You can send some stop signal or some sort of control function takes place. I've seen them to where they've drawn out many different configurations just based on what the operation or process is doing. But these can be used in different process operations. They can be mounted in different ways, but a lot of times these are used in larger areas to where you may have a person walking in that if they walk too far, it may create more of a risk to that individual. So there may be safety areas and warning areas. So with this, you've got more of a configurable functionality to it. Just a couple examples. You take a look here from examples of where scanners have been utilized in different facilities. Another example used on an AGV, you can kind of get a view of the different configurations, different zones that are set up. The green may be a warning zone. If something was to break that zone, it may slow down. If you break into the red zone, it may come to a complete stop. There may be some sort of enunciation. There may be some sort of response that's given when you go into the red zone. So this again is touching bases on how configurable it is. Then we also have vision-based protective devices, so like 3D presence sensing. So like a safety eye. You'll have a series of cameras that may be set up that are monitoring a certain area. With these cameras, what they would do is monitor just motions in the area. They have different configurable zones to where if there's motion in a zone that might be a safety zone, it shuts down. So those cameras are constantly monitoring from an above view, from a 3D perspective of what's going on the floor, what's going on maybe in the area. When those areas are broken, it's going to send some sort of signal to either stop the process or alarm some sort of way. So you can see just based off of the example there, the warning zones, detection zones, and you'll see the actual operation and then the developed curve. If that person was to walk into either one of those zones, some sort of function would take place. Once they get too close, it should stop the process from working. Some different advantages / disadvantages. It protects anyone in the hazardous area, so very similar to the other two. You can protect large areas. So again, this is something you would want to mount way up in the air to monitor a large application. This is a large process that you can monitor in 3D. So it'll know based off of how you configure what's equipment and what is an actual person, or this could also be an AGV because you might want to have cohabitation. There may be an AGV that might go off track that heads toward the process. Your safety yard would be able to see that and then therefore create some sort of stop, some sort of signal to say something's not right, and then mitigate the risk. This permits easy and safe access to the hazardous areas for repetitive operations and may eliminate the need for mechanical guarding. Because if you think about it, it's monitoring everything from a 3D perspective. So if something happens to break the area, something should happen. Disadvantage, they're sensitive to polluted environments. So if you've got a very dusty area and there's a lot of particulate in the atmosphere, it's going to see that. It may cloud it up. It may start to accumulate on the cameras. So this becomes a bit of an issue for any area that you might have particulates in the air. It's sensitive to reflections and lighting conditions. Again, this is cameras. So if you've got a light pointed right at it, it may create blind spots for the lighting conditions. For the not lighting conditions, but the lighting conditions may cause a problem for the vision sensing portions. It's, again, way more expensive, and it's limited to machines that can be immediately stopped. So a lot of times, as I said, this is like you got a robot cell to where it needs to stop. Something needs to happen pretty quick. It's monitoring at all times. So this is a nonstop monitoring of equipment that could possibly either destroy the process, hurt someone, or the process could be out of whack and may create issues within itself. So an AGV might be heading towards functioning robot arm. Robot arm can't see it. Safety eye does. Then it comes to a stop. Now you've mitigated your risk and the process can continue. Then we got radar-based protective devices. These use like 3 volumetric motion sensing. They're also very good for large and complex areas. And a lot of times what you'll see is multiple heads. With these radars, what you generally get is the same thing you're getting from a scanner. Like it's very similar. You're going to have like a certain area, but this is like a cone. So instead of it being a very flat surface, now you're getting more of a cone shape that's coming out of the sensor head there. And with these sensors, they can be connected to where it can actually monitor a full area. So instead of just monitoring parts and pieces, you can actually monitor the entire area, creating more of like a 3D image of a specific application. So if something happens in that area, one of the radars is tripped, then something should happen. If you've got it set to certain radars can be tripped, it's configured a certain way, certain radars can be tripped when certain processes are happening, you can actually configure it for that as well. So up to 6 sensors I've seen as far as what's been used. I know with our radar system, we can use up to 6 sensors connected in series to basically monitor an entire area. So we're starting to see the vision side of things starting to grow a little bit. Not only do we have products like the safety eye, we've got radar now, with scanners becoming a big thing. Now we're starting to actually be able to monitor areas from a different perspective, not just there's something there. We now have actually presence sensing, not just verification like maybe like proc sensors or codes and mags and stuff like that. Advantages, disadvantages. Again, robust to optical and environmental disturbances. So this actually works in the inverse of the safety eye or a safety eye type vision system. These are going to see right through all the smoke, dust, or whatever particulates you may have in the air, because again, this is with a radar sensing, not necessarily vision. This is more on the radar side of things. It's got volumetric detection, robust to vibrations, no precise alignment needed, easy and intuitive configuration interface, and not affected by objects left in the area. So you can actually leave something there, train your sensor heads to not see it anymore, and now you can continue on with normal functionality within your system. Now, if it happens to move, next time it's going to say there's something in the way. It's going to say something's there. So you want to make sure that if this is like a toolbox or something, get those out of the way. If it's not giving off any vibration, it doesn't necessarily care. It can ignore those. But generally what you want to use these in is those atmospheres where you may have dust or particulates that are in the air. These are going to take care of that problem, and they will see because they're based off of vibration. Disadvantages. They are optimized for protective of large areas, but that's where you're going to start adding up costs because of sensor heads. So the more sensor heads that you have, of course, you're going to start to develop more of a cost. These limited to machines that can be stopped immediately. So again, this is like larger areas. You can have them in certain places depending on the amount of sensor heads, but you wouldn't want to utilize this type of technology if you could get by with maybe a code or a switch or some door interlock. That it kind of starts to build outwards. So as you're creating a larger or more complex system, this is what you would want to be utilizing. Pressure sensitive. These kind of devices provide a quick means of a signal to stop the machine. So if you stepped on it, something should happen. This is more pressure versus presence. So instead of being in an optical world, this is more as reality based. You're going to step on something and something should happen. If you step on it a certain way, something could happen. These could be programmable functions all through each one of the little sensors that are within the mat or the safety guard that could be used to do something else. I've seen sometimes these are in place to where you have to step on them for something else to happen. So to keep it, and not necessarily to keep it from happening, but to make something happen. Big note, because pressure sensitive devices cannot restrain an individual from reaching a hazardous area, these devices must only be used on machines that can be stopped mid-cycle. So again, this is just a mat. It's just something in place to where once it senses the pressure, something should happen. This isn't going to keep someone from doing anything. If the system has, let's say, a ramp down or ramp up, they're going to get right in. Something can possibly happen, and the risk is a little higher in using a mat versus using maybe mechanical guarding or some other interlock that's on mechanical guarding. So again, advantages and disadvantages. Very low maintenance. These, once they're in place, that's where they are. A lot of times the maintenance that will come into it, if it's getting a lot of usage, sometimes they could wear out, the sensors could wear out to where you may have to possibly replace the mat. But once in place, the mat's going to be the mat. It'll do what it does. It definitely provides a visual reminder and warning to the personnel. So it's not something that they won't see. They will see these devices in place and have a full understanding for what happens when they step on them, because something should happen. Disadvantages are they cannot be easily relocated when the machine is moved. So a lot of times if these are in place, they're there. To take them back up, some manufacturers have them certain ways where they can be moved, but sometimes they're there on the floor for a reason. They can become very expensive for large areas. So if you're trying to use this on an entire floor, it could get pretty expensive if you don't necessarily need that much. If it's a larger area that doesn't necessarily require you to have any functionality that way or this way, it needs to be right here in front of the machine, you could be possibly creating stoppage time, because if the functionality is the same throughout, someone could step over there and actually stop the process from working unknowingly. You want to make sure that the surface beneath has to be flat, because again, these are sensors. You wouldn't want to have, a pressure point on your sensors, because you can break those pretty easily. And it has to be in a place to where it's not changing its direction. So as far as its location is not on a ramp, it's not on steps. You can configure it to where you can do those things, but it's like literally buying separate mats. You kind of want these on flat surfaces to where you can just determine if someone is on it or they're not. Two-hand control, two-hand trips. Again, these are devices that are used both hands at a fixed location, just basically to remove the hazards. So you have to do something with both hands before functionality can either continue or you're doing it to stop something. So this is a good check to keep hands. This is to keep personnel outside of the hazardous area, because they have to verify that they're in a place. They have to verify they're in a safe location before the function can actually, or the risk can actually take place. Again, advantages, disadvantages. Operators' hands have to be in the right location. So, of course, it's decent. It's good for verification. It can be adapted to multiple operations. So it can do various different things. You may have at one cycle, it does one thing. And the next step in the process, it may do something different. These can be set up. They're a little bit of configurable just based off of what you want to do with your design or design concept. Disadvantages, it only protects the operator. So if the operator is there and they're going like through a press sequence, if anybody else is around, they now can mitigate, or they now become an issue or to the hazard. The equipment becomes a hazard to them, because nothing is there to protect or stop them from having the issue. Now, if the operator was to let go when they got close, of course, now that's a different perspective. But generally, these aren't going to protect anyone else. They protect the operator. Enabling devices, used when personnel must enter hazardous area to perform work while allowing safe motion. So a lot of times you see these on like robot pendants. So very similar to the two-hand control, to where something has to be pressed for something to continue. You may have a jog mode, or you may have a run mode that's all the way down. These may have different configurations. It may be different pressure points. Sometimes it may just be one button to where you press down and something can happen. But generally, these are in place to verify that the equipment can't start up without or stop without some sort of control. So these are going to be outside the equipment. They'll be on the pendants for robot cells. So this is going to be an enabling device to where it's verifying if the equipment is ready to run based off of the operator. Whoever is controlling is in control. So again, advantages. Gives the operator control of the motion inside the hazardous area. And of course, built into all the new robot teach pendants. Disadvantage, it only protects the operator. If someone else is there and they're relying on the operator of the enabling device, if they happen to let go of that device by accident, now that individual becomes at risk. It also has ergonomic issues of sustained activation. So a lot of times what that's referring to is if you're holding it down, it may create carpal tunnel. It may have some issues there where you're dealing with, it's getting a little stressed to hold that down. So you might not want the same operator to continue to make the exact same process moves over and over and over. They may need a break. They may need to say, okay, let's switch out because my hands are tired. And then emergency stop devices. These are your e-stops. This is very basic. Stop and emergency stop devices are not safeguarding devices. They are complementary to the guards. Protective devices, awareness barriers, and signal signs, safeguarding methods, and safeguarding procedures. The different types that can be used for emergency stops are push buttons, pull cords, foot operated switches, push bars, and rod operated switches. So we've seen these everywhere. E-stops are probably the most commonly used guard switch or guard locking switch or interlock that we've most likely dealt with in our coming and going. And then we've got just a safe solution for your application. So sensor and control technology. This is a good snapshot of the different devices that I've mentioned throughout the presentation. You see how they're used. If you're not sure of how they were implemented into an application, this is a good overview of what those processes would entail. So you see your scanners and e-stops and magnetic switches, codes. But just give you a little opportunity to take a look at that. And with that, I will turn it back over to Adrian and take on some questions.
Okay, great. Thank you, Brandon, for an excellent presentation. Just before I get the first question, I want to remind our audience that at the end of the webinar, to please take a moment to complete the feedback form. All right, so let's see. The first question here is, it's a little long, so bear with me. We use interlocks on doors, but many times mechanics have to perform minor machine adjustments. A bypass key is used in the interlock to keep the power on. So lockouts are applied because they need to jog the machine. OSHA requires alternative procedures to protect employees. We have trouble developing these. Do you have a template or an example?
I would say reach out to some of our consultants, and they will be able to at least take a look at your application just through some sort of risk assessment. With the leaving the keys in, you're kind of mitigating the safety, so you don't really want to do that. To dig deep down into the standards, you can find it there, but why not use a consultant, someone that specializes in it, and they can get you squared away. I hope that answers your question.
Okay, the next question is, when purchasing new machinery, such as CNC mills and lathes, does the manufacturer usually build in the safety devices to OSHA standards?
That's a yes and a no. It depends on if that OEM maybe has some training, maybe has certifications in understanding the machinery safety. If not, they'll basically go by best design practices. Again, this is something that you would want to do a risk assessment on. Generally, in OEM, if they're going to have safety devices involved, they've paid a lot of attention to the standards, and they're going to try to at least install per those standards. If you needed some further recommendation, yes, you could reach out to a consultant, and they could get you squared away with some sort of assessment to gain just clarity on if they're meeting or conforming to the standard.
Okay, next question. Is there anything wrong with using the pressure mat to confirm the operator is in the proper place and using a curtain or other device to stop machine in danger zone is entered, if danger zone entered?
Only if you're utilizing the stop time calculation. So if they're in a place on a mat for verification, it's almost like using the two hand. So they have to be in a location for something to happen. The only thing outside of that, the risk would be if someone else was to jump past them, bypass the safety, and now they're in there while they're still verified in the same place. That would be the only issue that I would see in that.
Okay, and this is related to that answer. What has been your experience with someone bypassing the two-hand devices?
Generally, per SOP, it's followed. I've seen in certain scenarios to where you've got the two hand and then it's guarded as well. So it may have two hand and you have other operators that could get in and possibly hurt themselves, but it's designed in a way to where they have to bypass not only the two hand, they have to bypass the mechanical guarding, and there may be some sort of visual inspection. So a light curtain or scanner might be in place. So I've seen that.
Okay, the next question, is an escape release always necessary when using interlock systems? For example, when a personal key system is used?
That would be something on a standard. I can't say if that's a shall or should, but it is a good practice. Like if you're going to have a way that you have to do work inside a cell, for example, and you have to close that door to use the teach pendant. So you have your dead man switch, but you have to close that door. Let's just say the power goes out. You're safe, but you're also now in jail because you can't get out. You may need some sort of egress or some way to get out of the equipment just based off of loss of power.
Okay, next question. Is it difficult to connect scanners and or light curtains to older machinery? And can all machinery be retrofitted with scanners or light curtains?
Yes. So a lot of times what you're just using is the flying lead. So there's certain conductors, color coded, of course, per the operating manual, it'll tell you what each one of them are. So you have your power and then you have different signals, you'll have different configurations. So as long as your, we'll say control system or evaluation device is set up to take those signals in, you'll be just fine. Doesn't matter what your safety system is or control system or PLC.
Okay. Are there applications where redundant interlocks meet the alternative means of protection standard under OSHA lockout tagout standard?
Say that one again.
Sure. Are there applications where redundant interlocks meet the alternative means of protection standard under OSHA lockout tagout standard?
I'm guessing what you're asking is if you were to use two interlocks in place of using a safety interlock. So two standard interlocks, that will come down to within its manual, it'll tell you its rating. If it's not rated properly, you can go through some sort of like a SIL rating, a performance level rating, and just using our software, we use Pascal. If it's not to a certain performance level, then that performance level won't be reached. And by putting those two devices or those two redundant devices in place in a safety system, it may reduce your overall performance level because it's going to take the lowest level of whatever the component is, the safety component, the lowest safety level component. So it could actually create issues for you. I would say just get a safety rated device. I know sometimes it's a little bit more expensive, but it will make you compliant with the standard.
Okay. What's the difference between an interlock and an instrumented protective system?
An instrumented protective system. Interlock is going to be something singular. So you've got one interlock. I mean, if you have multiple interlocks, I can see it that way. Within a system, there may be multiple devices. I'm hoping I answered that correctly.
Okay. Couple more questions. What if I don't know what is the best guarding option for my specific situation?
I would seek a consultant, get a risk assessment done, so where you can get a verified understanding of what needs to be done for you to reach compliance.
Okay. Let's see. We did this one. Okay, we are scheduled to do a retrofit to alter a line in our plant. Can I just use the guarding systems we used in the last setup?
You could. I would say verify yourself if all risks are being mitigated. If you do see any risk that could possibly arise based on maybe new space, there may be a new piece of the equipment, a new portion. It's just verification. You got to go through your own analysis on that. But another question that I would say, reach out to a consultant, get a risk assessment, and therefore you'll have an understanding for your safety design concept if you're meeting the certain specification and standard.
Okay, and this is the last question. What is the best guarding system?
It's flavor to taste. That one there, it depends on your application. I would say if you've got a very large and robust system, it may require some mechanical guarding with interlocks that has some vision systems in it. So there's not necessarily a best, it's what's best for you. I tend to see on smaller applications, you can get by with a couple interlocks, some door switches, and you'd be just fine with an evaluation device, such as like a PNOS multi. There have been larger ones that didn't necessarily need a lot of electrical components. All they needed was just mechanical guarding, just nice fencing to go around it, and it was fine. It was equipment that didn't need a lot of in and out, so that took care of the risk. It mitigated the entire problem. And then there's others that are very large that require a lot, all the way down to a safety PLC. So it's generally flavor to taste.
Okay, great. I'd like to thank our speaker, Brandon Cox, for a great presentation, and our sponsor, Pills Automation Safety. On behalf of EHS Today, have a safe and productive remainder of your day.
Thanks, everybody.